Hi guys, this is Bob. Today I will talk about the fatigue and how to draw a SN curve. Basically, SN curve is to represent the material fatigue failure. And fatigue failure occurs when an object fails after a number of repeated loading and unloading cycles. Fatigue occurs because of imperfection in the object. A microscopic crack at a critical area of high local stress will grow slightly with each cycle until the crack is large enough to cause the ultimate failure. Failure is not as simply defined as when a part of break. However, it is defined as when a part does not operate as intended. The ultimate failure describes the breaking of a material. Moreover, an inspection of the surface after final fracture often reveals where the cracks has gradually enlarged from one benchmark to the next, until the section is sufficiently weakened that the final fracture occurs on one final load application. The beach-marked area is known as the fatigue zone. It has a smooth, velvety texture developed by the repeating pressing together and separating of the mating crack surfaces. The fatigue zone contracts with a relatively rough final fracture. So now we know what is a fatigue failure. Then we move to the SN curve. This is a table paper usually used to draw the SN curve. As we can see, the vertical axis is S, which means fatigue strains of the peak alternating stress. And the horizontal axis is N, which represents the life, the cycle. And after some number values are calculated by a specific method, certain image will be obtained through this table. Now, only the basic information of this curve is shown here. Moreover, numerous tests have established that ferrometals have an endurance limit, defined as the highest level of alternating stress that can be withheld indefinitely without failure. In the plots, the endurance limit is defined as S.n, where the prime indicates the special case of the standard test. The SN plot can be represented in a linear, semi-log, or log-log coordinates. Before drawing the SN curve, there are some important tables that I want to show you. The first one is the surface factor. And I will give you some seconds to take a look at this table, and it will be very useful in solving the problem. And here is the another table. It is a generalized fatigue strains factor for ductile materials. This is also important and including even more information. So I will also give you some times to read this table. Okay, then I think it's enough time for you to read the table. And I want to talk more about the SN curve. The SN curve for a given steel can be drawn using only the 10 times 3 and 10 times of 6 cycle strengths. The 10 times 6 cycle fatigue strength is defined as Sn equals to S dot n times Cl times Cg times Cs times Ct times Cr. This will provide you later. In this slide, I have listed the 10 times of 6 cycle and 10 times of 3 cycle. The 10 times of 3 cycle fatigue strengths for different types of loading are given in the table. So do the 10 times of 6 cycle. The fatigue strengths at any number of cycles can be graphically determined using the SN plot. Okay, so this is a sample question. You have to pay much more attention on the words that I use baseline. These data and key points are very useful to you to solve the sample question. First, because of it is an axial load, so the S 10 times of 3 equals to 0.75 SUST equals to 0.75 times 150 times 1 equals to 112.5 KSI. Next, Because this is a piece of steel, so the S dot n equals to 0.5 SU equals to 0.5 times 150 KSI equals to 75 KSI. Then assume that the room temperature is Ct equals to 1. From the table, we can tell that the Cl, Cg, Cr equals to 1, 0.8, and 1 respectively. And the Cg and Cr assume average value. So in another questions, if they didn't tell you the specific number, just assume. Next step is to find out the value of Cs. We use this table. As we can see, the question told us the SU here is 150. So we use two straight line to figure out the value of CS, which is 0.9. We choose a fine ground or commercially polished line because the question told us that. The final step is just to multiply each value we got, and we can get Sn equals to 54 KSI. Okay, so here's the time to draw the Sn curve. Sn curve is drawn by the spots and lines. So as we can see in this image, the main points like 112.5 and 55 are put in the cycle 10 times of 3 and 10 times of 6 represently. Just use the spot and then connect it. Finish. So how to estimate number of cycles for a certain applied stress? It's also simple, just to use the same table. For example, we use 3 times 10 power of 3. And we also draw two straight line and corner at the curve. We can tell that the stress is 100 approximately here. That's everything for this video, and thanks for watching.